Hey, welcome to the Smarter Grid. I'm your host, Dr. Nate, and in this series we explore all the engineering and digital aspects of the power grid. So that's everything from relay protection, control, and automation to cyber engineering and communications. Today's topic is virtual protection and control, VP and C. So not to be confused with VPC, virtual private cloud. I know we have already all these acronyms in the industry. And as we talk about virtual technology, especially as it relates to cloud infrastructure, VPC is a very common acronym. So we don't want to confuse that with virtual protection and control whenever we're having these types of conversations. So we're going to look at kind of the evolution of protection and control over time. And the initial, we're talking 100 years ago, tried and true technology without a doubt, where you have what are called electromechanical relays. And these guys actually are based on principles of physics. As you get more amplitude of current or voltages or less, there's changes in springs and coils that these electromechanical relays will then operate, right? Amazing technology, but it has a lot of limitations, So for instance, for one protection function, you're looking at something about this tall and this wide. And as we get into, something like today, we look at a technology called microprocessor-based relays, where this 100 electromechanical relays can roughly reduce down to 50 microprocessor-based relays. And these guys are some of the initial multifunctional, multi-purpose-based relays, microprocessors. So instead of, here everything's analog, these little guys actually will convert the analog signals over into a digital signal, do some mathematical calculations, fast Fourier transforms, all kind of cool mathematics. And then based on that, we'll detect a variety of different types of faults and then tell the breaker, open or close. As well as these little guys have now communications and networking capabilities, everything from serial to TCP, IP, Ethernet-based communications, even facilitating what's called transfer tripping, so some amazing stuff. And then as we keep on cruising here through time, we have here basically what's called centralized protection and control, where you think of what a lot of people advertise as the digital substation or 61A50. And then even then, this gets reduced and can get reduced even more so to basically just one or two servers. So you think regular blade servers, like a Dell server. Granted, some of the capabilities inside have to be a little, souped up, but still, nonetheless, it's a single form factor, 1U or 2U form factor, and it's reducing the massive footprint here over time into this, and it can actually increase the capabilities and reduce the complexity of all the wiring, all the physical contacts, and bring that down. Basically, you're moving that complexity from the physical wiring to the code, to the software that's running on these guys. And really, it was seen here, and then as you can keep on going, decreases the complexity of the physical wiring, but it increases the complexity of the software. And then kind of what's down here, we'll come back to that here in a second. So this is 100 years, probably the past 20, 30 years. This is actually now, and then maybe in about the next 15, 20 years, we'll be right there. So looking at this over time, right, we have a breaker here that's connected to these electromechanical relays, EM1 all the way out to some EM electromechanical relay N. Here, this is kind of a similar thing where we're trying to control this breaker, and here is our microprocessor-based relay 1 all the way out to some microprocessor R, and this is a reduction, right? So we can say N over 2. And this basically being a switch here, whereas before we didn't have remote control capabilities, right, with these electromechanicals, and now these relays, network-based, they can talk up to a switch, which can then talk to a remote terminal unit, which can then come all the way up here to SCADA. And by the way, y'all, right, don't forget that good old trusty firewall in there for cybersecurity. And then, looking at this over time, we have this transition here now to this step which basically we have the same breaker. We're performing some monitoring of the currents and power that's flowing through this breaker or this piece of equipment. And you have your instrumentation transformers here, which then goes into a merging unit. And then we have our centralized protection R1 all the way out to some centralized protection R, let's actually do sub N over maybe 16th, right? And then these guys, very similar, can just plug, almost plug and play into the same switch, into the same RTU to give visibility up for the remote operators. And then kind of bringing it all the way over here to the right, same thing, we have our instrumentation transformers. So you think CT, PT, current transformer, potential transformer, and then here we have our merging unit. And basically what sits here is just a server, just a single little server. And the idea being you can have virtual machines or containers that run on this guy that are basically doing all of this logic that's being performed right here, and then it gets reduced, and we can reduce it all the way down into one little 1U blade server. And kind of this evolution over time here, where we're going next is there's a lot of people looking at maybe doing the cloud. And that's very interesting because with protection and control, there's a lot of time requirements. But that's definitely going to be a topic for another day. I hope you enjoyed this one. Feel free if you have any questions, comments, corrections, definitely love corrections. Feel free to put them in the comments below, as well as there's going to be a link provided. Thanks for joining us today, and I look forward to seeing you in the next one.